which we also have log 12 raised to the power 2, because 12 times 12 is 144 to the base 12. Therefore, if the 2 go behind the log 12 to the base 12 will cancel to give is same thing as 1. Therefore, we will now be left with 2. The second tells us how to subtract logarithm from, for example, log 70 minus log 7 is equals to log 70 over 7, which is equals to log 10, which is equals to 1, and log 56 to the base 8 is minus log 7 over 8 to the base 8 is equal to log, since they having two of them having the same base, we divide it, we are now be having log 56 over 7 over 8 to the base 8, which is the same thing as log 56 times 8 all over 7 to the base 8. Then if we do our multiplication and then cancel out, we will now be left with 8. 7 divided by 56 will give us 8. That means log 8. Now we'll be left with log 8 squared. When to go behind the log, we will now be left log 8 to the base 8 is the same thing as 1. Therefore, we'll be left with 2. The third tells us how to find the logarithm of a power. For example, log 8 is the same thing, is equals to log 2 times 2 times 2 is 2 raised to power 3. Therefore, we now have log 2 raised to power 3, which equals to, since the 2 is raised to power 3, we can move the 3 behind the log to have 3 log 2. For looking at another question, another example, we have that log 8 over log 2 is the same thing as log 8. We have already gotten our log 8 to be 3 log 2 all over log 2. So therefore, log 2's will cancel out to be left, so that we'll be left with 3. Also, log cube root of 17 to the base 7 is equal to log 17 raised to power minus 1 over 3 to the base 7, which is equals to, that 1 over 3 can actually go to the other side to come log 1 over 3 log 17 to the base 7. These formula are, of course, equivalent to the law we apply in numerical calculation. 1. To multiply two numbers, add their logarithm and find the antilog or the result. 2. To divide two numbers, subtract the logarithm and find the antilog of the result. 3. To raise a number to a given power, multiply the logarithm of the number by the power and antilog the result. Change of base. The formula which tells us how to change from one base to another is equals to log s to the base b, which is equals to log x to the base a over log b to the base a. Proof. Suppose that log s to the base b is equals to u, so that b raised to power u is equals to x. Take logarithm to base a, log b raised to power u to the base a is equal to log x to the base a. Therefore, u going behind the log, we have u log b to the base a is equals to log x to the base a. Therefore, u, making u the subject of the formula, we have log x over to the base a over log b to the base a. Therefore, substituting back the we are told that you let log log x to the base b is equals to our u. Therefore, we replace it u. Therefore, we replace u by log x to the base b. Then we have log s to the base b is equals to log s to the base a over log b to the base a. Example 4. Evaluate log 17 to the base 7. Solution. We are given log 17 to the base 7, which can also be written to be equals to log 17 to the base 10 over log 7 to the base 10, which our log to the base 10 is our log 17 to the base 10 is 1.2304 all over our log 7 to the base 10 is 0.8451. Therefore, using our table, we have that we will now have 10 raised to power 0.0899 over for log 10, log 7 raised to power 7. We now have 10 raised to power 1.9270. If we do if you add the two base, if according to the law of indices, division is subtraction. Therefore, we now subtract the bases to have 10 raised to power 0.1629. Therefore, if we do our antilog of 10 raised to power 0.1629, we now have 1.455.